people who say things are aesthetic. And I was like, how about you shouldn't have like said that at all because you know you're really stupid. Now you're just trying to backpedal.
I've seen one nowadays.
Okay, children, let's all relax.
I've seen a one.
Okay, let me.
It's so weird how I've lived my entire life, not my entire life, and most of my life in the same city as with another name that I never take pictures.
Wait, here or
Okay. Full screen. Full screen.
Worried about being on.
Okay, so well, thank you everyone for coming. Those two of you that did. Really disappointed in the 98 other students that didn't show up today. I get this is the first day, and I gave you no like.
But everybody can drive. And nobody
Yes.
has like backup plans. Like I don't know how to drive, but like my dad's picking me up, so like I'm.
And I appreciate that. So, yeah, I'm live on YouTube, but it's fine. You can talk because it's only 3 of us. Okay, so make sure to like and subscribe. Click that bell up top for notifications of when I'm live next. So I have 2 things for you, children. I have this, which is content. Yes. And this, which is extra. Okay, not extra, but it's like stuff for you to like work on and fill out. Do y'all have highlighters?
Yes.
Okay, get those out.
What color?
It doesn't matter. Okay, I'm gonna close the door in just a second. Can I pause this live stream?
Yeah.
I don't think so.
Is anybody in it?
I can. No.
Yeah.
I'm gonna welcome everybody. Welcome. Okay, I'm gonna have to like. Yeah.
Oh, I'm leaving at 3.
I'm so she's gonna be mean her. Oh God, she's gonna love that. You better warn her.
Miss Taylor, I'm leaving at 3.
So it's just gonna be you and me.
Oh my God. Okay, so let's get into a massive chunk of the AP exam. I started with research methods today because it's one of the biggest sections of the AP exam. Glad to have people in. So, research methods. I think it's like 10%. This is, we're not going in order of this packet. It's on the front page, yes. So it says research and methods and testing. So this is much more information that I'm about to show you. But you can like highlight or add to it or whatnot. So let me flip to my annotated thing. So there are different types of studies. A survey, a case study. It's supposed to be 4, and then there's 4 technically. What's the one that we're missing? If I want to do study, I can do survey, I can do a case study or experiment. I'm missing something.
Naturalistic observation or a case experiment.
Yes, naturalistic observation, which is not up here. I don't know why naturalistic observation is not here, but survey, case study, and experiment. What is the benefit of doing a survey?
It's fast and
It can be done for free, and a lot of people can be involved.
Yes, you can hit a lot of people. What's the problem with surveys?
People could lie.
honesty.
Yes, people can lie. They're not honest, and they could have misleading questions or like biased questions where it's like,
Breaking it.
yes, the way that they frame the question, it might change how people respond. What is a good thing about, or what is a case study?
Shows that this causes this. Shows causation.
No, it does not.
No, it does not.
Case studies do not show causation.
I was gonna call it case experiment.
Okay. Case studies, do you remember this is just like an interesting story that like after the fact? It's like talking about Kitty Genovese or talking about like Jeannie who's in the basement. Those are all examples of case studies. But then an experiment, okay, and then I forgot to say, naturalistic observation is when you just watch people in their natural environment. You don't get involved, you don't manipulate anything, and since you're not manipulating anything, there's no independent or dependent variable. So it's not an experiment. You can't prove anything. An experiment, you can prove things with an experiment. You can manipulate variables and then see the effect. So let's talk. Sorry about that. Going back to case study, and I think we talked about this, or at least it was a Quizlet term under intelligence, but I guess you could have also put it under research methods. And I believe it's on the second page at the very top. It says longitudinal versus cross-sectional studies. So I think it was mentioned in intelligence notes and in the intelligence Quizlets, but I guess, it's a study. So you can put it under research methods as well. If I want to measure someone's intelligence over time, longitudinal means that I'm going to follow the same group of people for their whole life. I might give them an IQ test when they're 10, another one when they're 20, another one when they're 30, 40, 50, and 60. So what's a great thing about testing the same people over the course of their lives?
That's accurate.
It's accurate. It's also really valid and reliable because it's the same people. But what are some drawbacks of testing the same people for their entire life?
Not everybody's the same.
It's not diverse.
Okay, that's probably going to be a really small group if I'm going to be following them throughout their life. I'm not going to be following thousands of people throughout their life. Maybe 20, maybe. What else?
Time.
It would take your entire life to do that survey or that study because it's their entire life. Plus, people die.
Yeah. They could all die from
right. It's I was going to test them again, but this one got in a car accident, this one had cancer, and it's I don't know what their intelligence is when they're 80 because none of them made it till 80. So a lot of the time, people do cross-sectional studies, which basically means I'm going to take someone who's 10, another person who's 20, another person who's 30, another person who's 40, and then test their IQ. So a great thing about the cross-sectional studies is that it's really fast. I can do it in a day. But what's the bad thing if I'm testing different people?
They're not the same.
They're not the same people. So if we're testing IQ over ages, that 10-year-old has access to a smartphone, and it might be in a really good school versus that 80-year-old. I don't even know if they went to school. They might have worked on their family's farm, or they don't have access to a computer and they don't know and so they don't have as much information. So cross-sectional studies are faster. Longitudinal studies are more reliable and more valid if you want to get information.
Plus, it's cross-sectional because somebody could be having a really bad day one day.
Right.
That's your anger chart. And they're grrr.
Right.
They're the most nicest person ever.
Right.
Yeah.
Okay. So let's talk about what are you talking about that? Let's talk about more about experiments, since that's one that's going to be tested a lot. The idea versus independent and dependent variables. This is on number 4. Do you see that? On number 4. It says with the different variables in this group. So what is an independent versus a dependent variable?
Independent is whatever is being manipulated in the experiment. Independent is whatever is being measured in the experiment.
Okay, whatever you manipulate is going to be the independent variable. The effect of the thing you're manipulating is the dependent variable. So if I want to see does sunlight make plants grow higher, taller? The sunlight is the thing I'm going to manipulate. Are all my plants going to be put in the sunlight?
No.
No. Why? What do I need? I probably need a couple groups to split my plants up. So if I put some plants in the sunlight, where should I put other plants? In the closet, without sun. The plants that are getting the sunlight, that have the independent variable, they get the sun. What kind of group is that?
Experiment.
That's the experimental group. The other plant group that's in the closet, that's the control group. Because I'm going to see, does the independent variable, in this case the sun, actually make my plants grow taller? So independent variable is the sunlight. What's the dependent variable?
It's the height.
The height of the plant. Yeah, the height of the plant. And so what could be a confounding variable? Does anyone remember what confounding variable is?
It's that extra outside force that also contribute to the growth of the plant.
Yes. So it's something that would.
It's not supposed to
yeah.
It's you don't know
Yeah, it's gonna mess up my experiment. Maybe I have a confounding variable might be I get some like soybean seeds or something, some bean seeds, but then some of my bean seeds have like little diseases on them. Like it has like a fungus or something, and it stunts the stunt. Hold on, get him. My door is locked. Done?
Yeah.
Oh, that was fast. Ow, I just hit myself.
I didn't take my test fast.
Yes, that's true. You do take the test.
Thank you.
Hi.
Thought somebody was joining.
No.
Wait, I have a good example on notes we wrote. It was like trying to prove that smoking causes cancer, but confounding variable is like you like.
What could cause
it's
cancer
like
that's not
cancer
smoking?
About smoking.
Yes. So if you like live in like what is it, Beijing or something that has really bad smog, you're gonna have more cancer. If let's say you just are predisposed to have cancer anyway, yeah, you have a high genetic trait of getting cancer, those types of things. Okay, so that's independent variable is what you manipulate, and then the result of that is the dependent variable. And then we just talked about the experimental group versus control. The experimental group, they get the drug, they get the sunlight, they get the, if smoking causes cancer, they get the smoking. While the control group doesn't get that. Well, if I am giving the experimental group a drug, what would I give the control group?
Placebo.
A placebo. Okay, so it's not that they're going to get nothing. They have to get something.
Sugar drops.
Yum.
Yum.
Okay. Yeah. How do you get rid of confounding variables? How do you assure that you're not going to have anything that comes in and messes up the experiment, like soybeans that have fungus or people that are predisposed to cancer? Just randomness. Yes. So it's a really big, it's a big thing that you need to know, the difference between these two things. Random selection versus random assignment. Random selection versus random assignment. So there's this population that I want to study. Let's say that I'm doing an experiment and I want to study if vaping in high school causes cancer. Well, I'm not going to grab people in like the business world. Why?
Because that's just one group. It's not.
But who did I say I wanted to study? I said smoking in high school. So I want to study high school students. So that's my population. So everyone that's in high school is in my population. This is population. Ooh, when am I ready? Population. In that case, it's high school. I don't want to test everyone in high school. That would be way too much money. So I'm going to get a sample of the population. What is it? A selection. So this is the selection is like who from the population is going to be in my experiment. Who from the population is in experiment? Not all of them though. I'm gonna get some. Yes. What does random mean?
It's like
You don't have like specific.
There's a technical definition for random. It is everyone has an equal chance of being selected. Yes.
Yeah,
So you
like
can say draw out of a hat, or assign everyone a number, like a student number, and then randomly pick those. So random, everyone has an equal chance of being selected from the population. Random assignment, though, is okay. So you have this random selection. I'm going to take these people right here. This is my random selection, also called random sample. If you see random selection or random sample, that's the same thing. Okay, now I've got like 100 people from high school. I've got 25 freshmen, 25 sophomores, 25 juniors, 25 seniors. Now I need to split them up into what?
Groups.
In my two groups, experimental and control. So that's random assignment. Once again, it's random. Everyone has an equal chance, but maybe since we're talking about two groups of like experimental group or control group, I could just like flip a coin. Like or I can roll a die, and all odd numbers are the experimental group, all even numbers are the control group. But these two things, random selection and random assignment, get rid of confounding variables. That is something you have to know. Those two things together, random sampling / selection and random assignment, gets rid of confounding variables. Because like if all these people have, oh, I'm predisposed to cancer in my family. If it's truly random, then those people with cancer in their family are going to be equally distributed between all the groups. So then they kind of cancel each other out. You're not going to have like a whole bunch of people with cancer in one group and no one with cancer in the other group. They're going to be equally spread out if it's truly random. So what are the odds? And then we were down to 1. Okay. All right. So what's can I erase this?
Yeah. I'm good. I feel like a slight interrogation.
Where were you when we learned about experiments? Okay. What's a double-blind procedure?
Oh, it's where the experimenter and the people getting experimented on are both like not biased. Like
It gets rid of experimenter bias. Is why we do it. But what are they not knowing? What are they blind to?
Who's like in the groups. Like,
Okay. I don't know if I'm in the experimental group or if I'm in the control group and I'm getting the placebo. I don't know if I'm getting the independent variable or if I'm not. And so experimental or double-blind procedures avoid experimenter bias. Do you see that?
Yes.
Okay. And then it's like 3 lines down. It says helps avoid experimenter bias.
Yeah.
Okay. Do you remember talking about the Hawthorne effect?
Yeah, I have it down here. Production went up. Oh, that's like an example. Yeah, like Hawthorne effect. It was something like he went around like the boss went around being like, let's see, like
Everyone's productive.
and then they were like, oh, boss is around, got him.
Right, which make them more productive either way. So like productivity went up in both groups because they're being watched.
Yeah.
So just being what Hawthorne effect is like just being in the experiment itself
Cost change.
because costs change and therefore is a confounding variable. So you almost can't, it's hard to get rid of confounding variables, but random selection and random assignment help do that. Okay, so let's see what we got next.
I hate when that happens.
We talked about placebo, we talked about random selection. Okay, okay. Do I need to talk about graphs of positive and negative correlation?
No, that's easy.
Okay. Positive correlation means if you have more of an independent variable, you have more of a dependent variable. And negative correlation means more of independent variable leads to less dependent variable. So like some things that are positively correlated is more studying and being at tutoring equals higher grades on your AP exam. Woo. But a negative correlation means that more, let's say, time hanging out with your friends and not coming to tutoring leads to less of a score on your AP exam, a smaller score. See, more of fun time, less college scores. More studying, more scores. So the positive and then a negative relationship. And remember, there could be no relationship as well, where it's like a scatter plot, where it's like more of this doesn't change any of that. And remember, we're going to get a correlation coefficient. Do you remember this?
Yeah.
If it is like closer to 1, it's a positively correlated graph. And then if it's closer to -1, then it's a negative correlation. And if it's 0, then there's no correlation.
It's right under the random selection.
Yeah. Okay, so what I did in the margins is just do like a little, I drew a little, like a, yes, you can do like a bar chart. You can do, what is it called when you have dots? A line graph? Dots?
I don't know.
That's a line graph, right?
People in the YouTube use comments down below.
Yeah, help me out here. 0 people that are watching or have given a like. 19 minutes in. Thanks. Yeah, we are. Time flies when you're having fun, Katarina. Okay.
Don't call me out like that.
Okay, let's talk about standard deviation and this curve right here. You need to know this curve. This is the normal bell curve. You don't have to know all of these like decimals, But do you know what a z-score is?
Probably somewhere in my notes.
Okay.
I remember.
The measured distance of a score from the mean.
Okay, that's these numbers, +1, +2, +3, -1, -2, -3. That's a z-score. So if I don't know, it would say like, how many, I don't know. Let me just give you some numbers. Okay, so this from one standard deviation around the mean. So here's the mean, at 0. This is the mean, which is the average. It's also the median, which is if you line the numbers up in numerical order, it's the one in the middle. And it's the mode, which is the most, oh crap, no. Yeah, that's right, it's the middle. And then mode is the most occurring score.
Yeah.
But in a normal bell curve, those numbers are all the same, mean, median, and mode. So like in IQ, the mean, median, and mode is 100. And so like, if that's 100 IQ, and all normal bell curves, 68% of people fall somewhere between one standard deviation. 95% of people fall between 2 standard deviations, and 99% of people fall between 3 standard deviations of the mean. Yes. So, but of course, like the standard deviations change in terms of like how far apart these are. So like I could say, hey, the average on the test was an 80. And you're like, well, what's the standard deviation? Should be your next question because no one cares about the average. But if I said, okay, standard deviation is like 10 points. That means there's 10 points of grades between each of these. So 70, 60, 50, 90, 100, somehow someone got 110 type of thing. That is a huge range. So the bigger the standard deviation here is like a big number. There's a huge range. And so like that means 68% of people fell somewhere between a 70 and a 90. 95% of people got between a 60 and 100, but there was that small 99% of people. So very few, just a few percent could got like really low scores or got over 100 with a curve or something. But the smaller the standard deviation, it's only 2 points. Well, then these numbers, this percentages stay the same of 68, 95, 99. But this would be like, the average is an 80. Standard deviation 2 points, 82, 84, 86, 78, 76, 74. Small range. Basically, literally everyone's getting an 80.
So the smaller the standard deviation, the smaller the range will be like numbers.
Yes, and the more people are closer to the average. The bigger the range, not too many people are that close to the average. So knowing the average of the test grade is like one thing. It's really important to know the standard deviation because that's going to really tell you how far away you are. Did I get a 30 when the average was an 80, or did I get a 74 when the average was an 80? Okay. Okay, before I get to the ethics part, on the front page, it talked about validity and reliability, which we talked about in terms of IQ tests and when we talked about like standardization, when we talked about intelligence. But here in this packet, it's bringing it up in research methods, which is actually probably a better place to put it. But the 2 big names you need to know are validity and reliability. So if you take a mock AP test and then like another mock AP test and then the actual AP test and you all get the same score, then those tests are reliable. You're going to get basically the same score no matter how you test it, maybe on different test days or half the test one day, half the test the next, or form A versus form B or whatever. It's even talking test, retest, or split half tests. You're going to get the same scores. But if you take like an online test and you're like, wow, I got a 5 on the online test. And then the day that you take the AP test, it's like, I failed, you get a 1. That first test wasn't reliable because that was like, it said that you did well and you didn't. While validity is like testing what it's supposed to measure. Like the AP psychology test should have AP psychology questions.
Or it's just like the measured criteria of like, does the test actually have like the right subject and the right question?
Yes. So, I'm sure people have gotten tests before. They're like, we didn't even talk about this in class. Like, I have no memory. We didn't talk about this. We weren't prepared for this. This wasn't in this unit.
It's almost here.
Yeah. Then that test is not a valid representation because a test is supposed to measure something. And if I put questions on the test that we didn't cover, it's not measuring the thing that it's supposed to measure. It's measuring like your guessing skills or measuring your test taking abilities, which is not what I'm supposed to be measuring in the first place. And then it even talks about at the bottom, it says use operational definitions. Do you remember that?
Sure. Because I look at the thing it's explaining right now.
Let me read to you what it says.
What it says.
As you're thinking about that, you need to start coming to tutoring. Otherwise, you did all of this work all this semester long, and you're not going to get any college credit. You need to come to tutoring, and I will see you soon. Yes. Did you find it?
Found it.
Okay. So tell me what it is.
It's defined procedures.
Okay. Oh, Lord. We have someone knocking at the door. Yay.
What a turnout.
My God, I am going to murder all of your classmates. You have a legitimate excuse for not being here. You were taking a test.
Well, it's for like
Well, I mean, there's a 9-week test for A-push tomorrow.
There's an AP test for psychology.
There's an AP test for A-push too.
That's true, but not everyone's an A-push. There's
Yeah,
D-push,
there's a lot of D-push and they're seniors.
and there's OSH, and there's seniors. Yes. I'm going to kill all of you. I'm currently live on YouTube, so I will be posting this.
Okay,
But, Yay. Josh, do you remember what operational definitions are?
It's like right there.
Okay.
It's like the tip of your tongue. It's hard to retrieve the message once you stored it.
It's like define exactly what you're going to do in the experiment.
Yes. Why do you need to define exactly what you're doing in the experiment?
Because it's ethical.
It's not ethical. It's not because it's ethical.
So it can be replicated.
So you can do it again in the future. Because you're all like, I'm going to test, and I think we talked about this in class. I'm going to test whether like chocolate increases aggression. And it's like, what is chocolate? And then what is aggression? First off, it has to be like when it comes to like, you have to define what the independent variable and then the dependent variable is. So the independent variable is chocolate. So like, what is that? Okay, so it's going to be like 2 ounces of dark chocolate given every hour. Okay, but the dependent variable is aggression. But remember, oh my God, I'm going to misspell aggression. 2 G's?
Yeah.
Yes. Okay, what is aggression? Well, the aggression has to be something that is a behavior. A behavior is something that you can measure. Gracias. An aggression is a behavior that you can measure. You can't say like anger thoughts. Yeah, this is tutoring. Welcome. You can. Oh my God, we're tripled. We're like up by triple. This is like the last thing we're covering. I'm not going to tell them no. Come on in. I'm waiting for you. Let's go. Yes, please. So in case anyone in the hallway gets like, I smell intelligence and learning, they can like.
Can we get sticker?
You can get. I will. What? Yes. It's fine, Ruben. It's totally fine. Ah, look at you, state of pet memory.
Yes.
Actually, you probably have one of the worst seats.
I like to see the students use this like to see them.
Okay. I'm actually gonna put this over here before I forget. Okay, we were talking about Josh, did you say ethical because of the title?
Yeah.
No, I just haven't clicked. I apologize. Well, it's not actually conformity. It is using like cues to help like trigger context. Okay, so give me something that is a behavior that would be a behavior of aggression.
Like punching.
Okay, they have to punch.
Yelling.
They have to yell.
Like, can you like, it's like absurd. Well, like kind of glaring.
I guess
Like frowning. Like, if you're
frowning. You can that would be easier. Frowning. So you can't say like angry thoughts. You can't be like thinking upset or being upset. First off, being upset is once again subjective. Like I don't know what being upset is. It has to be a behavior versus like a mental state. So operational definition is defining these independent and dependent variables so you can replicate. In the future, someone years from now is watching you're looking at your research and they're like, I want to do that experiment again. Well, I'm going to need 2 ounces of dark chocolate every hour, and then I'm going to see if they punch, yell, or frown. Done. Experiment. Okay. Now let's talk about what's it called? Ethics. Do you remember DRIP? DRIP. It was a what's it called? It was a homework video that we did, and then DRIP.
interesting. Don't remember it.
DDRIPP. Those are the ethical guidelines when doing an experiment.
Oh, maybe.
No. DRIP. DDRIPP. These are the things that you have to do for it to be ethical. Okay. It was like PowerPoint form.
It was on the binder check. Yeah.
Yes, it was. Yes, it was. I was hoping, because we didn't have time to talk about it in class, so I was like, well, I'm going to sign up for homework, and I know they won't going to do it, but if they do it in the binder check, even if they copy someone else's, at least they're writing it down. So D means deception, as in don't. Unless deception is totally part of the experiment. Does anyone remember an experiment where deception was involved?
I can only think of an example of I can make up an example of
No, like an experiment we talked about in class. The experiment requires that you continue.
Oh, the shocking one.
The shocking one. If people knew that people weren't really being shocked on the other side, it wouldn't matter if they went along to the extreme because they knew that it was fake. So they had to deceive a little bit because that was part of the experiment. The other D is you have to debrief. That means after the experiment's over, you have to tell them what the results were all about. You have to debrief. Did I misspell debrief?
DDBRI.
Except after C.
You know, there's more exceptions to that rule than things that follow that rule.
Okay, yeah, it's like how A-E-I-O-U, and then sometimes Y, but nobody cares about that.
Yeah. Well, it's all Y is not a vowel unless you look at the word try or Y. And there is a vowel. Okay, R means you have to right to withdraw, meaning what?
They can
leave at any time. Can anyone think of an experiment that they talked about where they didn't they didn't really let them leave. Right to withdraw.
I was thinking of the Stanford experiment.
Yeah.
And then I think
The
Stanford prison experiment.
Oh, that's right.
Yeah, you're right.
Okay, cool.
Y'all just said it at the same time. Okay, what's I?
Informed consent.
Meaning what?
They must have consented to the study.
Yes.
I feel like that's a little bit so for the double blind procedure, the Hofmann effect.
Yes.
Isn't that kind of you're already messing up your experiment a little bit because now they're being I made an experiment.
Well,
kind of
no. I mean, okay.
Yeah. Okay.
That's not an unethical thing because they were at work being watched by their boss. That's not unethical. That's just their daily life. But being an experiment, like the shocking experiment or the conformity experiment, they have to be told oh, would you like to participate in this experiment? I'm not going to necessarily tell you that's fake. So the deception is still there, but you can't just, we're going to give you a drug without your consent. I'm going to as you're sleeping, I'm going to swallow when I'm going to put it in your throat and then rub your throat so you swallow it.
That's a thing.
That's a thing.
That's weird.
Because it's what do you, it's I'm choking on something. You're choking on the placebo. And then all of a sudden it's not double blind. Okay, and then privacy. I saw this FRQ a few years back, and it was, oh gosh, it was, the teacher was doing like an experiment with memory with her students, where she had kids study a certain way and then another class study a different way to see if like their memory changed, who would do better. And then she posted everyone's scores on the door. That was the experiment in the FRQ. And it was like, what is ethically wrong with this experiment? Is that she posted the information. She posted the results. I can't be like, hey, Josh got a whatever grade on his test. I can't do that, because that would be against his privacy rules. And then protection to do no harm. Right, which is why we rarely do social experiments anymore, like social psychology experiments, because you cannot guarantee that one won't be affected. To allow people to think, oh, you shocked someone to death. Like that can mess them up, even though it's fake. Okay. There is, on like that second page, like at the top of the second page, I do want to mention the statistically significant thing, and then we will be done for the day. Okay, so all we did was research methods and testing. That is all we did. We didn't do intro to psychology. We'll do that a different day. But the statistically significant, do you see what it is?
Wait, which number is it?
It is right before number 8. 7's on the previous page.
Okay, so it's like E.
Yes, E. Okay, so like statistically significant, the definition of that is it means 95% of the results are not due to chance. So it doesn't say somewhere on there that it's 95%. Just know that it, like, write it down. That is 95% of the results are not due to chance. It is a statistically significant experiment where the results are statistically significant, because it's basically saying, hey, I'm not saying that this causes this, but it's got an A in not chance. I mean, if the results were different, if it was like, oh, about half my results were due to just complete randomness, then that's not science. That's not science at all. Okay, looking at this section of methods and testing does anyone have any particular questions before I end our live video on YouTube?
So like the top part of it, like 1 through 6, is that more like a personal kind of like out of like 1 through 6, which do you?
Wait, what are you looking at 1 through 6?
The introduction to psychology.
We didn't cover that today.
Oh, we didn't cover that.
No.
Okay,
We're gonna cover that, I think, tomorrow. I forget, because we're supposed to start on Monday, so we're a couple days behind. And research methods, I was going to span to 2 days. So even though we're a day behind, or 2 days behind, we're actually 1 day behind. But I'm so glad of the turnout. Okay. Looking. Anything that you're all like, ooh, I don't remember this, or ooh, this looks confusing, or oh, I remember being confused about this.
So I'm a little bit confused around like 9, where it's like animal research and then like human research. Is that just like the difference between? Like,
yes. If you're going to use animals, there has to be basically the only thing between humans and animals is like, why are you using that animal? You have to get your animals and ethically, like there are companies that basically breed animals just for scientific research.
Oh,
you can't go bag a cat in an alleyway and be like, well, come on, cat. I'm gonna shock. Right. You can't do that. You have to get them legally, and you have to why a rat instead of why in that experiment with that learned helplessness? Do you remember where they held the dog down to shock it?
Really?
Why a dog? Why a chimp? Why a rhesus monkey? Why rats? Why pigeons? So why that specific animal, and then get that animal legally. Don't just be going to the park and with a trash bag and round up animals.
That's like some scientists, not animals, probably animals, but
People.
scientists would pick up or just grave robbers.
Yeah.
Dig up bodies and be like, hey, scientists, want to see these bodies?
Yeah,
And be
that's-
let's go.
Uh-huh. Okay.
Trip is on number 10. I was looking at it and I was like, oh wow, Trip. It's right there.
Yeah, Trip. Okay, do you want to see some multiple choice questions?
Yes.
Okay, there's just a few of them. No, let's give me a good one. No, give me a good one. Give me a good one.
Josh, are you on this one?
I might, okay, here we go. Theoretically, random assignment should eliminate what? Sampling error, use statistics concern. It is D. Did I? Okay. Yeah, because I also had an arrow like drawn.
Really?
I didn't notice the arrow.
Yeah, the arrow from
I
last year.
noticed it, I just thought that you.
That I must have done. No, I didn't.
I thought it was something from something else.
No. Yeah, random assignment and random selection should get rid of confounding variables because then it spreads out all those people that are like, cancer runs in my family. It spreads them out so then they can't cancel each other out. I remember we had an FRQ at the beginning of the year about like, how do you make sure you get rid of confounding variables? And then so many of y'all said, don't let those people in the experiment. That
Easy.
no, yeah, just don't let them. Like, no, you can't not let them because then that would be a big sampling bias because those people exist in the population and not having them in the experiment is not a good representation of the population. Oh, everyone in here is whatever the case may be. What? Are we going backwards? Okay.
Oh my god, there's a fly. There's something flying near me and it needs to go away.
I'm sorry. When subjects in the experiment put a puzzle piece in the wrong place, the experimenter unconsciously winced. The experimenter not wince when the subjects in the control group put the piece in the wrong place. The wincing of the experimenter must be eliminated because it is.
I think it's D.
It is. It's another confounding variable. It's experimenter bias, which that's a name of that a confounding variable. How do you get rid of experimenter bias?
You don't put the experimenter with
Yes. What do you call that?
double blind.
Double blind. That is how you get. So like random sample, random selection gets rid of all confounding variables except for experimenter bias. So then you have a double blind procedure to get rid of experimenter bias.
I thought you were just really like disappointed. in me.
No, that was I was a
You were
hint.
like trying to. I thought you were like, oh, dude.
Oh God.
Yeah.
Two types of statistics are descriptive and inferential, central tendency and variability, sampling and correlative, parametric and non-parametric. A. I can either describe how people act. Hey, did you know that 75% of people make up statistics right on the spot? Or you can infer. Based on this, I believe that 10% of the blah blah population will not vote in the current election. Whatever it is, you're trying to guess how people react. With inferential versus descriptive is just describing how they react. Inferential is trying to like predict how the future will be based off of statistics. Of the following, which research method is most effective for studying unusually complex or rare phenomena?
Not me.
It's not B.
Naturalistic observation.
You wouldn't know it was a complex phenomena until after the fact. You'd have to be like at the perfect spot at the right time to watch them. I'd say it's D. Case study. It's just like think of
that's already happened.
right. Think of like Kitty or Kitty in the alleyway or Ginny.
Oh, the what's it? Getting bad energy like off or something.
Oh,
in case something that's already happened.
Yeah.
I don't know if it's like
Why are we going backwards? Okay. Click. Of the following, the strongest positive correlation would most likely be shown between what? An adult's weight and running speed, close friendships and happiness, sense of humor and years of education, visual acuity and salary. Remember, positive relationship means one goes up, the other one goes up.
B.
Yes, it's B.
That'd be so sad.
Adults' weight and running speed, really fat people. No, yeah, really fat people running really fast. No, that's a negative correlation. The fatter you are, you're probably slower. So this is negative. This is positive. This is probably no correlation, and that's also no correlation. Keep in mind, positive correlation is graph like this, negative correlation like this, and no correlation is a scatter plot. You can also do like bar graphs. Woo, positive, negative. Think of the slope. And last but not least, number 10, John wants to study the effects of school on the behavior of college students. Alcohol. Study the effects of alcohol on the behavior of college students. For his study, he spends 5 hours every night for 2 weeks at a bar near college watching how patrons act before and after drinking alcoholic beverages. The research method John is employing is what?
That's deep.
As the naturalistic observation. He's just watching them in their natural habitat. Oh, wait, there's more. How do you figure out median first?
You
arrange them from smallest.
Yes, and then it's the middle. What if what's an even number of numbers?
Like that.
5. Like, cause like 1, 2, 3, 4, and then the 5 should be in the middle.
What's the average?
Yeah.
Oh,
Yeah.
Well,
Because you might not have like,
right.
but it's like, it's what, 2, 3, 4, 6, 7, 9. Well, there's no middle number, but you take an average, which in this case is 5, but it might be like 10 and like 100. So you have to take an average. Yeah. Which one is the strongest relationship? Strongest relationship. You
Yeah.
say
B.
B?
Yeah.
Yes, B is not possible.
It's too high.
This means no relationship. This is a negative relationship. That's a positive relationship, but this one's closer to -1. Then this is closer to +1. So it is B as 0.89 versus positive 0.65. Yeah, 0.89. Negative or positive is stronger. Oh, we did that. No. Okay, that's good enough.
But the answer is no.
Oh God. Okay, so that is that. Hopefully more you can tell your friends to show up tomorrow. I know tomorrow is like a Friday, but I don't know. Maybe I'll bring some candy. I don't know. We'll see. So don't forget to like and subscribe and smash that what's it called? Smash that like button and click the notifications to get shut up. Okay.